Chemical bonding. Let's review mixtures and pure substances. Now, if you'll recall from Unit 1, we talked about mixtures and pure substances. So let's take a look. Pure substances are just compounds or elements, like sodium and chlorine, which makes salt, or H2O, which makes water, and helium and nitrogen are examples of elements. Mixtures are just a mix of pure substances. So if we take the two compounds, salt and water, and mix them together, we get salt water. It's a mixture. So with mixtures, you can have a mix of two or more compounds, or compounds and elements, or two or more elements. Valence electrons. Valence electrons are electrons in the outer energy level. Now, why would I have an E with a minus? Because electrons have a negative charge. How can you tell how many valence electrons an atom has by just looking at it? Well, we can't actually see an atom, but we can look at the periodic table. So if we look at the periodic table, we would look at the group number. Have you ever made a cake where you mix together water and flour and sugar and some other stuff, or maybe your mom or your grandma did, and placed it in the oven for a while, and out came something entirely different? Well, this is an obvious chemical change. So why would I say it's an obvious example? Think of all the different examples or different things that we could look at to see if there was a chemical change that occurred. You'd have the smell of it. You can always smell a cake baking. You have a color change, all right, because you have the golden brown on the top, or black if you burn it, okay. You also have something completely different when it comes out. The heat of the oven, the wet ingredients stick together with the dry ingredients, and eventually becomes so that you cannot separate them anymore. In other words, it changes bonds of existing compounds or makes new bonds with different elements. So, what exactly is causing the ingredients to stick together? A chemical bond. It is an attractive force that holds atoms or ions together. Now, ions isn't a completely new term to you, but I want to go back and review it a little bit. And this is not on your paper, so you may have. On the website, I am going to have these video links, so I'm not going to show these to you right now. But I would like for you to go back and watch especially the first one, What Are Ions? So it'll be a really good one. And also the properties of ionic compounds and what are ionic. Okay, so I lied. I decided I'm just going to make a different video about ions that way. We can go on with something, we can continue on with this one, and you can watch the ions. So why do these bonds form? For a chemical reaction to occur, bonds have to be made or bonds have to be broken. So most of the time we're going to be looking at least right now, why bonds form, why they come together. Remember, atoms want peace. And a lot of times I refer to it as they want to be happy. They want to get that full valence electron shell. Remember those 8 electrons that I talked about? Well, that is called the octet rule. So let's look at this figure here. We see that we have 3 atoms here, and let's see how they're going to satisfy this rule. You've got an electron here in hydrogen, electron here in hydrogen, and in oxygen you have 6 electrons in the outer shell. Well, It has that second outer shell. So it needs two more. Hydrogen only needs two electrons because it just has the one shell. Remember, it's the one that's kind of the oddball, it and helium, because it has just that one energy level. So when we look here, you can see that water has bonded, and you end up with 8 electrons now in the oxygen, but you also have 2 in each. We're going to wrap this video up and then go on and do some basic bonding, looking at some basic bonding ideas, and I'll show you that one on the next video. You'll need to get your worksheet out for it.